Okay, welcome to Chapter 6, another one of my favorite chapters of Trig. We're going to solve trig equations throughout this whole thing. And you have kind of done this before, but we're going to take it to a whole new level. Okay, so when are we ever going to use it? Here's just an example of a word problem in which we tie in a velocity type problem with, in the equation, a sine theta, and you want to know the angle. Well, we need to solve for our trig function in this type of example. Okay, and we will get to that at some point. But I just want to show you that there is a word problems, or this is why we have to solve them. Before we can actually solve them, though, we have to go and kind of refresh our memory. You guys all could probably solve this from Algebra 1, just to make you all feel happy inside. Yes, we are going to go back to this type of scenario. And how do you get x all alone? Divide everything by 3, x equals -4, right? So that's kind of a quick rehash on solving an algebraic equation. Same drill for trig functions, okay? You need to get the variable all alone. Well, the variable is going to be attached to your trig function, so I'm going to say it over and over again. How do you get your trig function all by itself? You need to add 1, so we get 2 sine x equals 1. Divide by 2. We need to figure out what angles give us a positive value for sine. Okay, so more times than not, and maybe some of you could jump to this conclusion, if I draw myself a picture where sine positive, one of them's in quadrant 1, and in every problem we're going to need 2 answers unless you're on a quadrant line. So I know it's 1/2, so that's the square root of 3. So I know that's a 30-degree angle. Okay, so I know one of my answers is 30 degrees. Okay, where's the other one? Where else is sine positive? In quadrant 2. And it's the same reference angle, but your answer goes from home base. How far away is that from 0 degrees? 150 degrees. Okay? Now these could be in degrees. All right? What if they were in radians? You would just say it's pi over 6. That's your original one. Okay? And then your pi over 6 shy of pi, which is just 5 pi over 6. So if it was in radians, that would be your answer. So you kind of got to figure out what the directions are asking, and that's kind of the process to do that. Okay? So now if I go to another example, 2 cosine theta equals 1. And now how do I know if it's in degrees or radians? It's what's given in this problem. Okay, notice I give you degrees, so all of your answers on these two will be in degrees. All right, so cosine theta, I need to get that all alone. I divide by 2. Cosine theta equals 1/2. It's kind of a similar scenario. Cosine theta equals 1/2. And by the way, you guys could take cosine inverse on this thing and get your answer too. I'm not going to say that you couldn't. It's just I'm trying to bring back old memories and try to help you out. So what's across from the square root of 3? That's 60 degrees. So I know that theta equals 60 degrees. And then you got to remember, where else is cosine positive? It's the x value, so it's got to be to the right. So that's just 60 degrees down. So the other answer would be what's 360 minus 60. So 300 degrees. So those would be my 2 answers here. Notice you're always getting 2 answers. Okay? I'm going to draw myself a line down the middle and do number 2. Subtract square root of 3. So I get 2 sine theta equals -√3. Divide by 2. Sine theta equals -√3 over 2. So on this particular scenario, if I draw myself picture sine negative, quadrant 3, quadrant 4, and if I draw my opposite as -√3 over 2 in both of them, I know it has to be a 1, and then this one's a -1. But what's across from, or what angle is dealing with the square root of 3? That's a 60-degree angle, and this is a 60-degree angle. So I know that theta is going to be, let's see here, 60 degrees beyond 180 would be 180 plus 60 is what? 240. And then I'm 60 degrees short of 360, so 360 minus 60 is 300 degrees would be my angle measurements. Okay? So once again, you get your 3 answers, your 2 answers for each time you go around. Okay? Now, there are scenarios in which you don't have all your signs combined. It's no different than if this was like an x and an x. You guys would want to get all of your variables on one side and the random numbers on the other. Okay? So I would subtract 3 sine t minus 3 sine t. And then I'm also going to subtract the square root of 3 at the exact same time just to save myself some room. And I would get 2 sine of my angle equals negative square root of 3. Divide that by 2. So I end up getting sine t equals negative square root of 3 over 2. Now notice this is the exact same answer as this one. Okay? So you would end up getting 240 and 300. No different than what I did on number 2. But what is that going to actually be your answer? Okay, you can't have this answer. Why? Look at your interval. It says 2 pi. So you guys need to just put this in radians. So it's the same exact drill as I did on number 2, since it was negative square root of 3 over 2, but I want it in radians. So your radian measures here are what? 4 pi over 3 and 5 pi over 3. And if you are unsure how to do that quick, you either could use your formula, or you guys need to grab your unit circles and practice that a little bit more. Okay? All right, this one. If I subtract 4, okay, so I get 3 sine t equals 0. If I divide by 3, it's still going to be 0. When is my y value at 0? Y value 0 this way and that way. So what radian measures is that? And I actually have it including 0 and including 2 pi. So if I run my formula that way, I have to start at 0. That's one of them. My y value, because this is what? 1, 0. This is negative 1, 0. My y value here is 0, so that's pi. And I want to include 2 pi because I am including both of them. So I actually get 3 answers on that one because of how my interval was asked and because I got an answer of when y is 0, so I'm right on that quadrant line. Okay? So you may have examples like that. Find all solutions in the interval 0 to 360 degrees. So I know all my answers are in degrees. And when I have to use a calculator to the nearest degree. So sometimes there will be a time when you guys don't get nice answers. So I'm going to bring all the cosines to one side. I'm going to add a 1 back. So I get cosine theta equals 5. And all of you should try this on your calculator right now. I don't know how to put, I know how to put 5 over 1 on a calculator, but I just want you to do this. If you take cosine inverse of 5, you get a big fat error message on your calculator, which that means there is no solution. It's an empty set. You can write no solution. You can write the empty set thing. But I want to show you why this is true. If you think about cosine, the regular cosine curve, what's its restriction on its range? Okay, it starts at 1. And then you go to negative 1, and it repeats itself. Will you ever get up at 5? Because that's what it's saying. What angle gets me to 5? It can't get there. It's too big. So if you guys have cosine or sine, and you have a number that's either larger than 1 or smaller than negative 1, it's no solution. Okay? It can't happen. So I just wanted to show you one example like that in this section as well. How do you guys solve that one? Going back to Algebra 2 or any other algebra class that you had. You always want to get it equal to 0, right? So subtract 5, that's equal to 0. And you're going to factor it. This might bring back painful memories or really fun memories. Multiply to 5, but add. So 5 and 1. We need to add to 9, though. Why did I put it that way? Because I know that 2 times 5 is 10x. And this is a 1x, and I need to make it 9, so I need the 10 to be negative plus. Okay? So that allows you to factor it, and now to solve, you just take each part separate. Okay? So 2x plus 1 equals 0. X minus 5 equals 0. So x is going to equal negative 1/2 if you subtract the 1 and then divide by 2. And then you just add the 5. Okay? So that's going back to the good old times. Why do I show you that? Because you might have to do the exact same problem. Notice I just showed the exact same problem. This is like 2 x squared minus 9x equals 5. There's a reason why I did the exact same problem, okay? Because I want you to be able to factor and then kind of work back and kind of see what's happening here. So I'm going to subtract a 5. I'm going to factor it the same way, except now your cosine t is like your x. It's your variable, but the cosine's attached to the t. So I would go 2 cosine t, and if you guys don't like that, then take the cosines out, put an x in, and solve, and then insert the cosines back in. So it's going to be a 5 and a 1, just like last time. This is the minus, this is the plus. To solve, now you take each parenthesis, no different than before, set equal to 0. Subtract 1, divide by 2. Cosine t equals negative 1/2. Can you solve that? Is it between negative 1 and 1? It is, so we can continue. Where is cosine? Negative. And 2 and 3. Well, that's an ugly triangle, but we're going to go with it. Negative 1, 2, negative 1, 2. So this is square root of 3 here, and negative square root of 3. So that means technically, if we think about this in degree measures, this is a 60 degree and a 60 degree. But do I want degree measures? I actually give you it in radians, so we need to do this in radians. So technically from here to there would be 120 degrees. But what's 120 degrees? In radian measures, that's 2 pi over 3. And then if I go 180 plus 60, that would be what? 240 degrees? Well, what's 240 in radian measures? That's 4 pi over 3. So that's how you go about finding your answers, okay? From a squared or quadratic scenario, you just factor it the same way, solve. That's only 1/2 of the answers, though. That's this one. Can I do anything with this one? Cosine t equals 5. Okay? Can you take, is it between 1 and negative 1? No. If you guys take cosine inverse of 5, we already talked about this, t will be the empty set. You don't get any answers from this one. It's too big. Okay? So if you ever have an answer that's bigger than 1 or smaller than negative 1, that will happen. So in this case, you only have 2 answers. There are times in which you will get them to work, though, and you'll get more than that. Okay? And then this one. This is the hardest problem of them all on purpose. I'm going to tell you right now, you cannot factor this one. Okay, there's no way you're going to be able to factor it. So we're going to do quadratic formula. I just want to do it once to refresh some of your guys' memories. So negative b plus or minus square root b squared minus 4ac all over 2a. You're welcome. You guys can sing Pop Goes the Weasel the rest of the day. Okay? So minus a minus 4 is 4. Plus or minus the square root of b squared. Well, negative 4 squared is 16 minus 4 times 2 times 1 all over 2 times 2. Okay? And now if I do this, it's 4 plus or minus the square root of 16 minus 8. That whole thing's 8. It's just 8 over 4. Let's see, square root of 8, that can reduce to 2 root 2 over 2. So I lied. Over 4. Sorry. And now I can divide 2 into all of these. So it ends up being 2 plus or minus, this 2's gone now, square root of 2 over 2. You guys do have 2 separate answers. So what I do, by the way, what does x become? What's your variable? Technically, that's cosine theta. Okay? So cosine theta, we would normally write x equals 2 plus square root of 2 over 2. So 2 plus square root of 2 over 2. And then my other one, I'll do that in blue. Cosine theta would be 2 minus square root of 2 over 2. And you have to do them separate. You have to calculate them separate because that's just the way it is. If you guys do 2 plus square root of 2 and then divide that by 2, cosine theta equals 1.7. Well, if you guys take the cosine inverse of 1.7, it doesn't work. Okay? So that has an empty set. No solution for this one. This one does not work at all. So we actually are only going to get 2 answers, hopefully, as long as this works. Let's see. 2 minus square root of 2. Divide that by 2. You end up getting 0.293. That's awful. You guys can't put that on a triangle, so you guys have to take the cosine inverse. Cosine inverse of 0.293. And you get theta equals 73 degrees. because to the nearest tenth, it lands about right on 73 degrees. Now this is a positive side length. So where is cosine positive? Quadrant 1 and 4. And since we know that our reference angle, our quadrant 1 answer is 73 degrees, how do you find the other one? Okay, you just know that the same reference angle is true, but in the other quadrant. So now if I think about going from home base all the way 73 degrees shy or short of 360 would put us at what? 287 degrees. And those are going to be your two answers for that one. Okay? So you may need to know how to do a quadratic formula and solve each of them separate. It gets long, and that's just the way it's going to be. Here's the assignment that we're going to do for this section. We will work on whiteboards. We will do everything we can to help you answer these problems. So I hope you have a great day.